Welcome to this tutorial. In this tutorial, we calculate the thermal efficiency of a simple ideal Rankine cycle in Aspen Plus program. Just to recap, the steam cycle that we have is an ideal simple Rankine cycle in which the steam enters turbine and 15 megapascal and temperature of 600 degrees C. The pressure in condenser is 10 kilopascal and the steam flow rate is 10,000 kilogram per hour. We did this simulation in the previous video. Now we want to use the calculator in the Aspen to perform the analysis of the thermal efficiency. In order to do that, on the left sidebar in the option for flow sheeting options here, the second option is calculator. So we select the calculator option and then a calculator is created by pressing on the new button. You can name this calculator to whatever you want. I leave it as C1, stands for calculator number 1. So I click on OK. Now the calculator is created. We need to define all the variables that are used in this calculation. So we add these variables one by one. First, we add, if you remember, to calculate the thermal efficiency, we need the work of the pump, work of the turbine, and Q from the boiler. So we add these three parameters. So we start with work of the turbine. I name it WT. This is a variable from a block. The type is block variable and the block is our turbine. The variable is the network that is produced and the units we take this kilowatt as the unit and the information flow is import variable. So the Aspen reads this value before doing the calculations. The next one is the work of the pump. It's similar to the work of the turbine, but the difference is that the block should be pump. Variable is the network and units kilowatt, and it's an import variable. The next one that we need is the Q of the boiler. I call this Q in, and then it's again a block variable. The block is our boiler and the variable is the net duty. Here, be careful because the units is calorie per second. It should be kilowatt. So we have the same units for all these three variables. It's also an import variable. So now we are done here. You can go to the calculate tab. We have two methods for the calculations, either a Fortran code or a Excel. I start with the Excel sheet. So you select the Excel and then you press on Open Excel spreadsheet. Then an Excel spreadsheet will be opened. Now you see the spreadsheet that is open. We need to go to the add-ins here. In order to define the parameters, we type a name. Let's say that we have the work of the turbine. We have the work of the pump. And we have the Q of the boiler. In order to define these three parameters name and connect them to the parameters that we define in the Aspen, we use this. We select the same cell. Here you select, this is WT, this is WP, and this one is, sorry, Q in. Now the efficiency should be equal to the work of the turbine. I use a minus sign because the work of the turbine is produced, and the value in Aspen is a minus value, minus the work of the pump, uh, work of the turbine, minus work of the pump, and then we multiply this by 100 and divide it by Q in. Now this is done. So what we do is that we save this Excel sheet, we close this, and then we rerun the analysis in Aspen. So we click on the next and we press OK, and we wait for the program to finish the simulation. Now the simulation is finished, and you see in the calculate tab that the Excel sheet calculation is done, and the efficiency that is calculated is 3.4, and we have no errors. We have also an alternative method that I can show you. You can use, and it could be easier maybe instead of using the Excel worksheet. And in order to use that, we need to define another variable, which is an export variable. We call this efficiency, and it's a parameter. And sorry, it's a parameter. And the parameter number, we just give an arbitrary number. Let's say number 1. The physical type, this is dimensionless. So dimensionless, unitless. If you want, you can insert the initial value, and this is an export variable now. So we go back to the calculate. Instead of Excel, we use Fortran, and in the Fortran window, you click on the Fortran sheet. You need spaces in the beginning, so make sure that you have it in the correct way. So the efficiency is equal to the uh, minus work of the pump, turbine, minus work of the pump, multiplied by 100, uh, divided by Q in. And here you check the Fortran declaration. It's fine, so we proceed. So we reset and rerun the calculations, and we wait for the outcome. Now the results available. So if you go to the left side, the calculator and the results, then the defined variable, here you see that the efficiency now is calculated as a written value. So Aspen reads the value for work of the turbine, work of the pump, and Q for the boiler, and then it calculates the efficiency, in this case 3.4, which is the same units as before. So see you in the next video.